We will be going into this video today, and it's about, well, pre-technological civilizations on Earth. Have they happened? But before we do, first I've got to say, I'm sitting in the Geo chair today, recliner, Geo recliner. I am not going outside. It is bitter cold, and that's coming from me. It's at least minus 10 Celsius right now, maybe more. I forget. It might be closer to minus 20. Yeah, this just happened like last night. It is winter, so, whatever. But this video, hopefully by the time I release this, it won't be so cold. It's January 14th, 2024 right now. This is a recent video, and I just want to say something. It's going to sound like right now that I'm dogging this video, and I'm not. I really love Spacetime. I think it's a good series. But the reason why I'm going through this video is because the host is not a geologist. He's a physicist. That's his background. Yes, he's smarter than me. Yes, he's more educated than me. But being smarter and more educated than someone doesn't mean they know more than you do in everything. That's not how that works. I have more of a geoscience, geology background than he does. Now, this video, I think it's interesting. It's linked below if you want to take a look at it. This one's going to be edited. I'm going to cut out the parts that are like ads within the video and stuff that doesn't really show what I'm trying to show. I won't even think I'm hiding something from them. That's why I'm linking it below, so you can watch the whole thing if you want. But anyway, you guys have heard me say this before. This is going to sound arrogant and pompous, but it's kind of true. Every physicist I've ever run into, and this is someone who was going to become a physicist if he didn't become a geologist. I mean, I never changed my major in college, but I did flirt with it a couple times. I'm like, well, what if I get a physics degree instead? But I never changed it, okay? So I kind of have an understanding from both sides a little bit, which is kind of unique too. We all have our specialties is what I'm trying to say. And we all have stuff we're really good at, and we all have stuff we're really bad at. So let's get started on this. Hopefully, this video's 20 minutes. Hopefully, this one will be about the same. Won't be too long, but you guys know me. All right, let's get started.
We are almost certainly the first technological civilization on Earth. But what if we're not? No, we are. But how sure are we? Really? A favourite way to estimate the abundance of life in the universe is the famous Drake equation.
First, before we get into this, too, I just want to say something about the Drake equation. I've actually ranted about this before, and I'm sure he's aware of this, too. The Drake equation is essentially just a fun little thing. It's not even really a scientific equation. There's no way to test this as of now, and it's likely that every variable in it, or close to every variable in it, doesn't matter. And people have tried to stick in extra variables and all that, and it's a mess. It was just something meant to be. Even Drake himself said, it's just the kind of thing I thought up. But, it's just take the Drake equation with a grain of salt, please. Just like there's Cavendish civilization levels. Take those with a grain of salt. It's fun to think about this kind of stuff, and it's healthy to think about this kind of stuff, but it's unhealthy to take this as like gospel. And a lot of people do. Like, I'll do a Cavendish, what is that, scale rant some other time. Sorry. I know I'm mispronouncing his name. But, different tiers of civilizations in a galaxy. That's what I'm talking about. Anyway, let's move on.
If we detect just one more instance of life or technology out there, we'll immediately be able to upgrade our guess at the probability of any given planet reaching that stage of development. But you know what would increase the probability even more? If we saw that it happens twice on the same planet. There's an extremely loose piece of evidence, not even evidence, maybe just a teaser that life may have started independently twice on Earth.
He's going to go back to the early Precambrian, the Hadean here, and I have heard of this, but let's hear him out first.
There's this zircon crystal found in the west of Australia that contains a tiny speck of carbon that looks like it was filtered through a living metabolism. It has a characteristic higher proportion of carbon-12 versus carbon-13 that plants breathe out. That speck of biogenic carbon was probably perfectly sealed in a zircon crystal probably from around 4.1 billion years ago, dating it to before Earth's crust was probably reliquefied by massive asteroid bombardment that should have extinguished all life. And that's a lot of probablys, but this is crazy given that the next earliest fossil...
First of all, when he's talking about reliquefying the planet's surface, that was called the heavy bombardment, and that was from about the formation of the moon to about 3.8 billion with a B years ago, plus or minus. It didn't really reliquefy the crust. We know the oceans were stable by then. So the heavy bombardment probably in the beginning was tough. And let me say something about these Jack Hill zircons. I've said it before, I'll say it again. Well, you might be like, well, these zircons, if you don't know anything about zircons and where they're found, you might be like, well, why don't we just look at the rocks around the zircons and see if there's evidence of life in those? Well, there's two problems for that. Number one, zircons only form in igneous environments. Two, the carbon, yes, they can have little carbon things. They can have impurities in them separate from the crystalline structure. That's fine. That's not a no-no. They form from hot igneous magma right away. The likelihood of this carbon being biologic in origin, it's almost zero. It's one of those things where we recognize we have today, when we see carbon 12-13 ratios in life, and we see carbon 12-13 ratios in these ancient zircons. Thus far, there must be a connection. That doesn't always mean there is. Is there an inorganic way to get this? Probably. Do we know it? We have a good idea. There's hypotheses out there. But, I mean, I see why he's doing this. This is a little bit clickbaity side, but it's not really clickbait because that is a viable hypothesis. We have no way to test it with the surrounding rocks. Why? Because the surrounding rocks that contain these zircons are not igneous. They are sedimentary. These zircons formed somewhere else and were included into the Jack Hills conglomerate and sandstone as grains. Okay? So wherever they came from is older than the sands and the conglomerates themselves. Remember, you can be younger than your youngest zircons, but you can't be older. These zircons are about 4.1 billion years old, but the sediment that they're encased in is at the oldest and likely a lot younger, 3 billion years old. So we can't use the surrounding rocks. And plus conglomerates and sandstones like that host these, their metamorphoses don't usually contain fossils very well anyway, even though when those rocks were deposited we had microbial life. Now he's going to talk about the 3.8 to 3.5 billion year old life, which no scientist disputes that the 3.5 billion years ago there was no life. We're pretty confident of that. Now let's go on.
In Australia and also in Greenland date to between 3.5 to 3.8 billion years ago, and that's after Earth re-solidified following its...
Like I said, Earth didn't re-solidify. It wasn't remoltenized, I guess, lack of a better word, because we had stable oceans at 4 billion years ago. So we were probably still getting whacked pretty frequently, but that doesn't mean that's a long time to keep a small, we think of Earth as big, but it's actually pretty small, a small rocky world as liquid form. I mean, you would have to pelt it nonstop for a very long time, and there's no way you'd have oceans on the surface. It's just, yeah. Anyway, let's move on from that.
If so, then abiogenesis, life arising from non-life, would have had to have happened again. But all of this is extremely speculative, and one reason is that it's really hard to verify the origin of life because these fossils are extremely scarce. Greenland and that little bit of Western Australia are the only fragments of land still left on the surface from that time. The entirety of the rest of the crust has been subducted, pulled back into the Earth's mantle by tectonic activity, not once but many times.
And this is also assuming plate tectonics was active 3.8 billion years ago. That's still a big unanswered question in geology. We might have had some crustal recycling mechanism, but it doesn't seem to be plate tectonics. It has to do with greenstone belts. you guys younger than me can worry about because, there's still things to know.
Record has been deleted, which makes it extraordinarily difficult to track the early rise of life. But if the geological record is so crappy, then in 500 million years, Earth's new inhabitants will have precious little evidence that we ever existed. So could we even know that we are the first technological civilization on Earth? And if we're not the first, that would have huge implications for our Drake equation, forcing us to update both the probabilities of technological civilizations arising from life and also our lifespan estimates for those civilizations. I know this sounds like some lizard Illuminati rubbish, but one effort to properly address an out-there proposal like this is in a paper by NASA climatologist Gavin Schmidt.
He's right. It's an interesting hypothesis, and that's what it is. It is testable. And he's like, it sounds like some Illuminati rubbish, but, if it can be testable, it's a hypothesis, and it's science, okay? I'm going to address why the answer to this question is no. And it's going to be from a geologic standpoint, not a climate standpoint, not a physics standpoint, all right?
And physicist and astronomer Adam Frank from a few years ago. They proposed the Silurian hypothesis, which asks whether pre-human industrial civilizations might have existed. The name is an old-school Doctor Who reference. I'll leave you to Google it and to...
My sister!
Yeah, it's great. Although in Doctor Who they got it wrong because the Silurians were reptilian race, and we didn't have intelligent reptiles till the dinosaurs, which were way after the Silurian period.
See what we're actually looking for. Let me be quite serious for a moment. I don't think such a civilization existed. Schmidt and Frank don't think that such a civilization existed. The burden of proof of such a claim is massive and massively on the claimant. And currently, there is no real evidence. The actual purpose of this video and of the Silurian hypothesis is to frame a very clear scientific question around a very speculative idea. So let's do just that. Broadly, that question would be, could a non-human industrial civilization have existed before us given our current lack of evidence of such? And expanding on that, if so, how long ago would it have had to have existed in order to be completely erased by now? And what traces of such might still exist that we could now look for? But first, to start thinking about what evidence a past civilization may have left behind, let's think about what our civilization will look like in the far future. Our species has been around for 300-ish thousand years.
There's something I want to say about this. You got to look at the geology today, too. Actually, the current climate and continental configuration that we have on this planet is rare. We are in a unique, rare history of the planet where we have ice caps at both poles, where we have ice ages, because usually the Earth is ice-free. We have more continents in one hemisphere than the other, in the north and the south. That's also rare. The continents are arranged in such a way where ocean currents are very diverse, because even when we have broken up continents, they tend to be closer to one another. Does that make sense? So we tend to have it. We have a large ocean on the planet now. It's called the Pacific, but we tend to have even larger ones. So, this situation we have today has happened in the past from a geologic standpoint. It's just been a very long time. The only time I can think of when it's probably been like this. You're looking at right before the formation of Pangea, okay?
But has only had a major impact for the past 10-ish thousand years of the Anthropocene era. By definition, this is named as the era of our major impact.
First of all, the Anthropocene is not recognized formally, but we'll get into it because I know he's going to define what an era is here, and he defines it incorrectly.
And that impact has massively accelerated in the 300-ish years post-industrial revolution. When you look at the world now, you might think that our constructions are the most telling signs of our presence once we're gone, but that won't be the case for long. The pyramids may have lasted millennia, but they won't last millions of years. All of our great cities will erode to dust, be covered up or washed away, be pulled beneath shifting tectonic plates.
That's actually not true, since most of our civilization is on the continents. The continents do not get subducted. And that's a key thing as to why, if there was another technical civilization like us, why we would see evidence of them. There's much more than that, and I'll get into it. But that's one of the key things that's wrong here. I mean, yeah, there's garbage on the ocean floor, and that stuff will eventually get recycled, but the continents won't.
Subducted. It'll be reforged into new rock in the mantle, and its geological memory almost completely wiped before it re-emerges, if it ever does. So will any signs of these works be apparent in the far future? The recycling of the crust means that anything older than 500 million years is pretty much gone.
See, he's talking about ocean crust here, and it's actually more like 400 million years. But I don't know if he knows that. Because, like I said, the continental crust does not get recycled, obviously. We have 3.8 billion year old continental fragments on the planet. You know, the old oceans are at maximum in the Mediterranean. There's a little patch that's like 0.4 billion.
But we do find plenty of fossilized dinosaur bones that are hundreds of millions of years old. So surely we'd find the remnants of a civilization that's only millions of years old. But that is not necessarily the case, because of the potential limited extent of the civilization both spatially and temporally. We have of course obtained samples of Earth's surface.
Okay, just want to say about that. That is something we don't know. We are a global civilization. You know, think of what you will of that, but that's the fact. Would any technological civilization in the past have spread globally? We don't know. It would depend on the nature of the intelligent beings. Maybe they don't reproduce as quickly. Maybe they don't like certain environments on the planet and won't even try to be, they may go there, but they may not like to move in there. They may not have that high reproductive ability and high, wanderlust that human beings have. It's very possible that a civilization could pop up on this planet with 2 arms and 2 legs like humans, be something else, and just only evidence of any complex civilization might be the size of Texas. Something like that instead of global. That is a possibility. We don't know that won't happen.
From many millions of years ago. Some of those areas are still exposed, but most we reach by digging or drilling. But here's the thing. We have accessed only a tiny fraction of a percent of the original Earth's surface from before the Quaternary period, 2.6 million years ago. And modern urban land coverage is less than 1% of Earth's surface today. So if a civilization...
Yeah, humans are concentrated, but like I said, we do exist globally. And so hence our evidence is global. It's at the bottom of the oceans. It's at the top of the Andes, top of the Himalayas. It's in Antarctica. If we just all poofed away tomorrow and then aliens came the next day, just saying that, they would see that we were a global species now. That evidence would deteriorate over time, but there's so many of us and so much garbage that it's going to take time. Plus, like I said, this is a unique configuration of the continents in geologic time. So, and they talk about the pre-Quaternary. We actually have a lot of that exposed. We have a lot of it. And it's diverse enough, spread out enough. I mean, there's practically, other than alluvial deposits and alluvial fans, river deposits, stuff like that, desert deposits. South of the 30 North parallel, there are no Quaternary deposits. North of the 30th, yeah, we get glacial tills, the ice advanced and retreated. But even a lot of that's exposed. You guys know that. I mean, I can take you to Ontario, where we have Precambrian rocks exposed. Greenland, where we have Precambrian rocks exposed in large quantities. So it's not, an exposure isn't really a problem. There's something else at play.
Just like us, existed a few million years ago, it's extremely unlikely that we today would have stumbled on their physical remnants.
No, that depends on the extent of the species. If they were global, we would be tripping over their garbage in a few million years. It's just if they weren't global, we would still see some impact, even in ice cores and stuff like that. And he's going to kind of get into that.
That includes cities and artifacts, but also fossils. The fossilization rate is so low that we've only discovered a small fraction of the species that ever existed.
That's true. That's very true.
Remember that the dinosaurs roamed the Earth from around 240 to 65 million years ago. They've been gone for a third of the time that they were around. And across those 180 million years, we have just a handful of specimens. By comparison, our 10,000 years of civilization is barely a blip in the fossil record.
That is true. When you're working with just time and natural situations, but we are creatures of nature. Yes, we are. But our impact is something the world has never seen before, and on a scale the world has never seen before. So this type of argument doesn't really say much, in my opinion. I see what he's trying to do, but it's kind of pointless.
Our industrial era, not even a blip. We can find T-Rexes, but we can't find T-Rexes from a particular few centuries.
That's true. That is true, but like I said, it's pointless. It doesn't mean anything.
I'll elaborate on the extent of the Anthropocene blip.
Oh God, there was that word again.
Our best way to trace geological time is in sedimentary rock. This is rock that originally formed from the precipitation of dead ocean things onto the ocean floor.
Well, not dead ocean things necessarily. Most sedimentary rock is clastic in origin, which means it's mechanically weathered from some sort of pre-existing rock. Either sedimentary, metamorphic, or igneous. The dead things are a small part.
Building up over millions of years. From sedimentary rock that's been exposed or from deep cores drilled into the ocean floors, we can analyze these layers to track changes in ocean chemistry, temperature, and biological content from these layers, which in turn reflect those same properties on a global scale. The entire Anthropocene will be represented by a layer only several centimeters thick in kilometers of sedimentary layers, with the industrial age a proportionally tiny fraction of that.
That isn't entirely true. Now, he's talking about things like sedimentary rates, but we as geologists have kind of given up on that. There's very few instances in Earth's geologic past, even recent. I mean, there are exceptions to this. It usually involves catastrophic events like a dam breaking or natural or otherwise. This type of thing is not entirely true because we have entered the subsurface. We do have vast landfills that are dozens of meters thick. We have dug out huge mines. We have done all sorts of things to the subsurface, dug out huge tunnels like the TARP project around Lake Michigan in the Chicagoland area. All these things are not going to disappear when we do. And they will fill in probably with sediments over time. But if our garbage is still there, our garbage is going to essentially become fossilized.
Perhaps millimeters at best. Although a far future civilization probably wouldn't find our bones or artifacts, they might find and recognize this wafer-thin layer in the geological record. As our structures and cities grew, so did our broader footprint. Anthropocene is the word for the geological era dominated by human activity. It's not quite textbook yet, but probably will be soon. Geological eras are periods of time reflected by distinct changes in the geological record.
That's completely not true. The problem with the Anthropocene, number one, is that no one can come to consensus on when this would begin. And it probably won't become a thing, especially if I have anything to do with it, because I personally, just knowing how Earth's processes work over time, we are giving ourselves too much credit, if you will, plus we're still here. I mean, why would you? I mean, the Anthropocene could end tomorrow. It could end 1 billion years from now. So it's not really something we want to do. We're technically in the Holocene epoch right now. But you have to remember, Things like eras and periods and ages and, what is that? Eons. Sorry, my head is fried today. Have specific hierarchical definitions in the stratigraphic code. That definition of era does not make the Anthropocene an era. An era, see, we got eon, right? There's no such thing as a super eon. We have eon. These are the basic ones. Era, period, epochs, and then ages. As you can see, era is below some things, but above a lot. And we are in the Quaternary period. A period is below an era. So even if you were to bust out the Anthropocene, it would only at highest rank be a period. It could even just be age or an epoch or something like that. But that is not how we define an era in stratigraphy and in geology in general. It's a hierarchical thing. These things are actually defined, standardized, and known. And you guys have heard me rant about this so many times. So he's wrong here.
The Anthropocene certainly qualifies. In fact, the geological marker currently being laid down
it doesn't qualify. And then I just gave you a bunch of reasons why.
In new sedimentary layers due to our activities bears an eerie resemblance to some of the transitions in the geological record from millions of years ago. So, to assess whether any of those previous events might be connected to industrial activity, let's take a look at the specifics of how we are going to confuse future geologists and paleontologists with the crap that we're sprinkling over the surface of the Earth that are already seen in some of the newly laid sedimentary layers. First, there are the more direct chemical and isotopic imbalances due to us making a bunch of weird stuff. Consumer waste like rare earth elements and plastics, nitrogenous fertilizers, and even steroids from large-scale farming, radioactive isotopes deposited globally from nuclear weapons testing that will last tens of millions of years. Then there's the effect of habitat destruction and species extinction, which won't be so much a distinct layer in the geological record as a sudden drop in the markers of biodiversity. But our main geological impact, of course, is climate change. Well, this is more than a speck. Over the Industrial Revolution, around 500 billion tons of carbon that's rich in C12 isotope has been pumped into the air. This is increasing the ratio of C12 to C13 in the atmosphere.
All right, so we got to be careful with this kind of stuff.
The rise in temperature associated with this new atmospheric carbon will influence the geological record in a number of ways. Alters the fauna that can live in those oceans and ultimately the layer on the ocean floor. There are many other known and unknown effects beyond these. So from all of this, it sounds like it'll be easy for a future civilization to see where we scrawled our "we was here" in the geological record. And if so, we should be able to find a prior one. Except that so many of these signals can be duplicated by natural phenomena. We'll come back to those natural explanations, but first, let's see if there are any interesting past geological markers that look anything like the one that we are currently forging. Our geological record contains several candidate weird layers that also represent massive environmental shifts. Some we understand well, like the Cretaceous-Paleogene boundary, which is connected to the dinosaur-hating asteroid hitting the Earth. And here we get to the Silurian hypothesis, which asks if any of these as-yet unexplained abrupt shifts in the geological record could have been due to an industrial civilization. But could some of the past hypothermals also have been triggered by something like us? Not impossible, but stand by for the debunkings. Then we have ocean anoxic events, a few of which are found in the earlier Cretaceous and Jurassic periods. These are characterized by a rapid drop in the oxygenation of the oceans, accompanied by a great dying of ocean life. Going back further, there have been several abrupt shifts since around 500 million years ago involving...
Okay, so he's basically sticking with the Cambrian to today, the Phanerozoic eon. And that's where you probably would focus anyway, because there we have zero evidence of macro life in the Precambrian, with the exception of the Neoproterozoic. So you can't build a complex multicellular global civilization. Well, if you can't build it, if you're single-celled, you're going to have a hard time. Could there be intelligent single-celled life out there? I don't know, maybe. I'm not a biologist. What do I know about that? But Precambrian civilization is very, very unlikely. So we're sticking with the Phanerozoic. What is different for the Phanerozoic than today? And we're still in the Phanerozoic. For most of the Phanerozoic, eras are Paleozoic, Mesozoic, and Cenozoic. And Cambrian, Silurian, Ordovician, Devonian, Carboniferous, and Permian are periods of the Paleozoic. The thing that's unique, not really unique, because it has happened before, but unique to today, is we had these things called inland seas. That's the layman's term. We'll go with that. The inland seas. As Rodinia broke up, that 1 billion year old continent, you got continents moving around. Generally, we think this is what happens. When you have continents break up, you have a lot of younger, more buoyant ocean crust. So the seas, to compensate, kind of spill upon the land a little. Some of you may be, and that happened during the Paleozoic and the Mesozoic, after Pangaea broke up. We had a lot of inland seas during the early the Carbon, the Cambrian, Ordovician, Silurian, and Devonian mainly, and a little bit of the Carboniferous, and in the Mesozoic, Triassic, Jurassic, Cretaceous periods, and even a tad after that. Okay, because when that asteroid hit, the continents didn't stop moving. Even if it wasn't a global civilization, any technological civilization likely would have been seaborne to some degree. Collect food, resources, they would have had to have been. And those things would have broken down when their civilization ended, whatever, and gotten buried. And we would see in those interior seaways, next to bones of marine animals, evidence of those civilizations preserved. We would likely see, well, it depends on if they use plastics or not, but that would be there. We would see probably any metal would be rusted out, but we might see the imprints of that. We may even find some of the creatures themselves. A big storm comes along, knocks over that oil rig. A ship sinks, but the bodies are still there. That kind of stuff. So in the Phanerozoic, we had a lot more inland seas. We had a lot more opportunities for such a civilization to be preserved that we don't have today. And although through most of the Paleozoic and some of the Mesozoic, we had an ice cap at one of the poles, we never had an ice age. Even during the Carboniferous, during the Pennsylvanian, coal swamps, hot, humid, steamy environments near the equator, and we had a southern polar ice cap. Evidence of an ice cap is not evidence of glaciation, and evidence of glaciation is not evidence of snowball Earth. Talk for another time. But anyway, so we would see something. Even if they weren't global, even if they were between two interior seaways or something like that, and they would still go out, and garbage would be dropped, catastrophic events would happen like storms, cyclones, hurricanes, destroying some of the stuff, and either in the sea itself or on land, rip it out and bring it down as part of the deposits. And our continental shelves are kind of like that too. We have tidal waves that come in and just wreck things, or tsunamis that wreck things and bring all that garbage out to the sea. Now, most of it ends up out in the ocean a little further off the continental shelf, but a lot of it doesn't. It doesn't go very far. It sinks down to the bottom, and it will get preserved or it won't. Depends. But some of that, just by statistics alone and probability, which some of it's going to get preserved. So at least for, I would say, 100 to 200 million years from now, there is going to be evidence that we were here. You might have to look for it, even if we disappeared tomorrow, because the things on the interior of the continents, most of that stuff, our roads, our bridges, stuff connecting large continental cities, those cities themselves are all going to be gone. That's unquestionable, because we are forming a great unconformity right now. We are doing that again. So that'll be gone. But the stuff along the margins and the stuff in those rare inland seas we have, stuff's going to get preserved one way or another. And us, we're so global that it's probably going to be a lot of junk. Even if we don't find a human skeleton, which we probably would eventually, we're still going to find evidence, direct evidence, that at least some sort of technological civilization was here. That's not unreasonable. And like I said, we've had an influence underground. So even if most of that was eventually formed into mountains and eroded, we would still have these deep mines and things like that that are in what we call craton stable areas that are not going to ever get subducted and are likely to remain stable for a long time. So stuff would eventually fill in with sediment. And if an alien race or future humans, whatever, started digging, they would find it. Yeah, let's move on.
Combinations of the signals that I've already described. And the further back we go, the harder it is to pin down the definite cause. So there's more and more room for our flights of fancy about dinosaur empires.
I love that image. It's a friggin' pig, people.
The biggest challenge to assessing the Silurian hypothesis is that natural climate shifts can duplicate so many of the current anthropogenic signals, from the change in temperature and the carbon situation to the different types of minerals being deposited on the ocean floor due to changes in ocean life.
That is true, but to use this kind of stuff, it's kind of hard to verify or falsify anything with an intelligent civilization, because it would depend how long it's around. My approach doesn't matter how long that technological civilization is around. If it's around for 100 years, it'll leave evidence, vast evidence. If it's around 1,000,000 years, it'll leave vast evidence. It doesn't matter. Attacking it this way is kind of difficult, especially when you don't have what you have, especially if all your ocean crust is gone, all your ice caps are gone, which is the norm. Earth does not usually have ice caps, okay? And the further you go back in time, these minute changes become more and more difficult to pinpoint, assuming they weren't global and catastrophic.
And there are many potential natural causes for climate change. For example, the periodic shifts in Earth's orbit characterized by the Milankovitch cycles, which we covered
Yeah, physicists love their heartbeat cycles.
Once upon a time, and which are correlated with past climate shifts. And if a signal is not caused by the climate change itself, then it might share a cause with that climate change. For example, spikes in heavy metals or rare earth elements can come from the manufacturing of technology or be produced by volcanic eruptions, which spew vast quantities of minerals and metals into the atmosphere.
You have finding heavy metals in an epicontinental sedimentary environment in the seas, as opposed to an igneous environment. That's the kind of thing you would have to look for. Where do you find these? I mean, obviously heavy metals in a lava field are not going to be from a civilization. But what if you find them in fluvial deposits going into an inland sea? So you gotta think about things like that too.
And oceans. Radioactive isotopes could be due to a nuclear program or due to a nearby supernova explosion. And these sorts of catastrophes and the associated climate change can also trigger the type of mass extinction that we expect to accompany our own geological bookend. That said, there are some things that we are doing to our own geological layer that would be hard to explain naturally. Some of the long-lived synthetic chemicals really have no known natural source, like some of these industrial fluorides. There are things like the chirality of molecules, the left or right-handedness of their symmetry that is strongly one way in nature but random in our industrial production. That past sudden climate shifts appear to have been significantly less sudden than our own. So if we found a shift that had occurred on a timescale of centuries rather than tens of thousands of years, that might be an indication. Speaking of timescales, we have a bit of a paradox here. A civilization which perished due to climate change would leave such a narrow record that it might be invisible. On the other hand, a much longer-lived and so presumably environmentally sustainable advanced civilization might produce minimal ecological disruption over millennia and so would be similarly almost invisible. In any case, distinguishing between these artificial and natural scenarios requires extremely careful analysis.
And here's the thing, too, and that's true, what he just said. I don't have a problem with that. But the thing is, a wasteful industrial society probably has to develop before a sustainable society. And depending on how long that nasty civilization like the one we're living have right now lasts, it may or may not be as prevalent. Like I said, we're still going to find, it doesn't matter if they're a tiny little layer. If we go extinct tomorrow, we're still going to have mines and tunnels and, all this other stuff. CO2 sequestration, I can never pronounce that word. All that other stuff. Fracking stuff like that's going to be evident. Underground activities.
So, have we detected the signs of industry in ancient geological transitions? No, we have not. But our search has also been quite limited. And this is the true value of the Silurian hypothesis, as Schmidt and Frank themselves emphasize. Is not to propose pre-human industrial civilizations as a likely explanation for past geological events. Rather, is to refine our understanding of what to look for if we wanted to find evidence of such.
That's a good point to make, it really is. I was going to say something here and I don't remember what it was. I'm getting old, guys. Getting old, and this is longer than 20 minutes. I'll try to cut back as much as I can. I don't remember what I was going to say.
Although it seems extraordinarily unlikely, the implications of discovering such a pre-human civilization would be impossible to overstate.
Oh, I remember what I want to say. What if there was technological civilization, but it wasn't from Earth?
Both for our sense of our own...
It's always aliens. This shirt, you can't see it right now. It's never aliens is what it says, and that's true. There it is. But what if it was? Anyway, that's a possibility too. But, when I say possibility, I mean unlikely possibility. And that may not leave an imprint further back you go, especially if they were just like on some sort of continent in the middle. Say the colony lasted, even if it lasted, 5,000 years, but if it didn't really expand, say it was just some little outpost or something, we would never know about it in that case. But that's not really a civilization arising, like they're talking about. That's something else, though. But, we could theoretically detect something like that, in theory, and now I'm using that word generically.
Place on this planet for our understanding of the likely abundance of civilizations in the universe, and it can even guide us to looking for past life, even past civilizations on other worlds.
I've declared war on the moon.
Do be quiet, Strax.
Too long the moon has hung, unmonitored and unsuspected in the sky. It has gained an enormous tactical advantage.
There's no one living there.
Then it is clearly time to act. They won't suspect a thing.
Who won't suspect a thing?
Moonites.
Starting with Mars, but most importantly, discovering an extinct people who reached...
Mars never had intelligent life. I would be willing, I don't want to say never, you never say never, but I would be willing to put money on that and a large amount of money on that.
The same or higher level of advancement as ourselves would give us a stunning new perspective on our own future and a profound reminder of our fragility. Perhaps enough of a reminder to allow us to avoid that hypothetical predecessor's fate and avoid becoming just another local geological blip that had once dreamed of exploring all of space-time.
Okay, everyone. I think that's it. Thank you for listening to my rants. If you have any questions or comments, please leave them below, and I hope you learned something.